Okay, so it seems like we've been doing a lot of different things with lines. We've been talking about their slope, we've been talking about their intercepts, we talked about how to graph them using tables. I'm really excited for this video because this is where it all finally comes together and gives us an awesome shortcut for graphing lines. The idea that goes into this is what we did in that last video, and I want you to write this little phrase down right here. If I know a point on a line and I know its slope, I can graph it. So there are two things you need to be able to graph a line. You need to know at least 1 point, and you need to be able to know its slope. There's this incredibly powerful, incredibly useful form for writing lines called slope-intercept form, and you've seen this before, I know you have, but we're going to explain where it came from in this video. So go ahead and for right now, write down slope-intercept form, and write down y equals mx plus b. I'm going to switch slides here to something we talked about several videos ago now. It was kind of our first introduction to graphing lines. So look back in your notes where we did these 3 problems. We were making our tables and graphing. These equations, numbers 1 and 3, are written in slope-intercept form, y equals mx plus b. This middle equation right here is not, but I can rewrite that guy. That's y equals negative x minus 1. And in green here, I'm kind of pressed for space, but I'm going to show you something really cool with these graphs here. I'm going to find the slope of my blue graph right here. I put dots on it. We've done this problem. Again, look back in your notes. If I do my slope, though, say I start right there, and I go down 3 over 1. The slope of this guy, remember m is for slope, is negative 3. The other thing I'm going to pick off this graph right here is the y-intercept. Seems kind of random for me to do that right now, but the y-intercept is at 2. So the y-intercept is 0, 2. I'll come back to that, but I'm going to do this for the other 2 problems as well. On this guy, my slope, I went down 1 over 1. So my slope is negative 1, and my y-intercept is right here at 0, negative 1. On my third problem, my slope is up 1 over 3, so that's 1/3, and my y-intercept is going to be at 1, 2, 3, 4, so it's 0, negative 4. I want you to take a look at that green stuff I wrote in, my slope and my y-intercept, and I want you to look at the original equations up here in black. This first problem, my slope was negative 3. There's a negative 3 in the equation right in front of x. My y-intercept was 0, 2. There's a 2 right there in my equation. Second problem, my slope was negative 1. Well, my number in front of the x there, it says negative x. You can really think of that as a negative 1x. My y-intercept 0, negative 1. There's a minus 1 right here. And on this last problem here, slope is 1/3, 1/3 right there. Y-intercept negative 4 right there. This is a huge deal. When you have an equation written like that, you don't even have to graph it. You can know some things about it going in. So the whole reason that this is called slope-intercept form is because when you look at it, you can see what the slope is, and you can see what the y-intercept is. The number that goes in front of the x in your equation is your slope. Just by looking at it, you don't even have to graph it or do the slope. You know that number right there, it's even an m. We've used m for slope, is your slope. And this b over here stands for your y-intercepts. So the number by itself is your y-intercept, and the number right here in front of x is your slope. Let's look at a couple examples, and I'll show you why this is such a big deal. So they're asking us to graph these 3 equations right here. And if we wanted to, we could go and make our tables, plug in numbers, plot the points, connect them, and graph them just like that. Or, if you know y equals mx plus b, you can do this a whole lot faster. I know, just by looking at this equation, it's y equals mx plus b form, this is my slope. So my graph is going to have a slope of 4, and this number right here was my y-intercept. So it's going to hit the y-axis at 0, negative 2. Look at the note you wrote to yourself at the start of this video. If I know a point on a line and its slope, I can graph it. Well, look at what we have here. We have a point on the line, and we have the slope. Just by looking at this, we know what we need to graph it. I know this point's on the graph. I can count off my slope. 4 means up 4 over 1. Now I have 2 dots. I connect them, and I'm done. No mathematical computation required. You just look at it and you can graph it, which is pretty cool. On my second problem here, y equals x, Well, I know the number in front of x in this one is really a 1. It's 1 times x. So my slope is 1. I know that already. Also, there's no number right here, but that really means I'm adding on a 0. So my y-intercept, the y-intercept is the point on this line right here, is at 0. It's right there. And then I just go up 1, over 1, and I'm done. I can graph it really quickly. On my third problem, unfortunately, y isn't by itself in this graph. So you can't use the, oh, there's the slope, oh, there's the y-intercept. That only works when y is by itself. But luckily, we've learned how to get y by itself. We practiced it a lot in chapter 1. I'm going to subtract my 3x, get negative 5y equals negative 3x plus 10. And I'm going to divide both sides by negative 5. So I get y equals 3 over 5, positive x, and then minus 2. So my graph has a y-intercept at negative 2. That's down here. And my slope is 3 over 5. I can go up 3 over 5. And then I just make my graph. So this is a nice, quick, efficient way to make graphs. And it really explains why we care so much about the y-intercept. It's just so easy to see from the equation that we use it in our problem.